Hello everyone, thanks for tuning in. This is for my pre-calc class. This video is going to entail how to do simple conic sections, and we are going to focus on parabolas. So I got 4 examples that are going to go with the worksheet for class, and so we'll dive right in here. The first one, the parabola we're looking for, the first 2 we're going to do actually are going to be up and down parabolas. So I'm sure you remember from Algebra 2 what parabolas look like. They're just U-shaped graphs that open up or open down. We actually have a bunch of formulas. We are going to do conic sections here where everything is in HK form. So we are looking at this H and this K, and that's going to show up a lot in the conic sections as either the vertex or the center of all of these shapes. So the first example we have here is above the graph here. We got x minus 3 squared equals 8 parentheses y minus 2. So the first thing we recognize is that 3 is the h and 2 is the k, because it follows this formula right here. So one of the things you notice here, it says x minus h, and we have x minus 3, so 3 is the h. So some of you are probably wondering, what if it is positive? So real quick, if I had something like x plus 4, then h would equal negative 4, because x plus 4 is the same as x minus a negative 4, and that helps you fit the formula right here. So going with this example here, we know now that h is 3 and k is 2. Some people like to think of it as the opposite, so that's fine as well. So I know that our vertex is at 3, 2. So if I go over to my graph, I go 1, 2, 3, up 2. I know that that point right there is my vertex. Now, how do I know if it opens up or if it opens down? Well, that determines from our p-value. Now, p is going to come from whatever's in front of the parentheses. So I'm going to take 4p and set it equal to whatever's in front of the parentheses. And in our case, 8 is in front. So I got 4p is equal to 8. And if I solve this for p, I know p is equal to 2. And so this tells us if p is positive, bigger than 0, it opens up. Or if p is negative, less than 0, it opens down. So therefore, p being 2 means it opens up. So what I'm going to do now is I'm just going to draw very generic. I'm not going to go real wide or real skinny. We're not going to get into that characteristic. But I do know that I am going to make a parabola that opens up. Now the biggest thing you want to do is make sure that you don't draw a V. We're not doing absolute value. And we make sure that we have a nice easy curve right there. Axis of symmetry. This will always be a dotted or dashed line. Okay, so a dotted line, and that's just what you remember from geometry. It's a dotted line that goes right through the center. We have a formula right here of x equals h, and so if we look at the one we did right here, we know that h is 3, so we want the equation. Make sure you write the equation. So x equals 3. So if I go over to 3, I'm going to see that I'm right in the middle, and I just draw a dotted line that goes right through the middle. And I will label that AOS for my axis of symmetry. And then we're going to have a focal point. Alright, so our focus point has a formula right here of h, k plus p. Now we know all those values. All of those values, okay, again, h from our problem was 3. K from our problem is 2, and we figured out P earlier, and that was 2. So I want to make sure that I have H, K plus P, so 2 plus 2. So that gives me a focal point of 3, 4. So if I go from the origin, I go at 3, 1, 2, 3, 4. And that is my focal point. One thing about the focal points is, and that's very important, is that the focal point will always be inside the parabola. Never have your focal point on the outside. If you do it right, that focal point's always going to be on the inside. Okay? So the last thing we do is we talk about a directrix. And the directrix is always outside. And it's always perpendicular to the parabola. Okay, so this one has a formula of y equals k minus p. Now again, we know the values here. K from the beginning is 2. Minus p, which we figured out was 2. So we have a horizontal line of y equals 0, which is right here, and I'll put it in a different color here. So our directrix is at y equals 0, so we actually have it right here on the x-axis, and I label that dir. So that's how you do a very simple parabola graph. This one opens up, axis of symmetry goes right through, focal points on the inside, directrix is on the outside, perpendicular to the parabola. So let's look at another one. Again, we got 4 examples here. So let's go to one here, still on the up and down parabola. Okay. So again, we're going to recognize right here h and k. Alright, so see how it says x plus 2? That means h is going to be negative 2 and k is going to be 4. Alright, so knowing that, my vertex is going to be negative 2, 4. So I go to negative 2, 1, 2, 3, 4. And this is going to be my vertex. Alright, which way is this opening? So again, I got to take 4p and set this equal to the number that's in front of the parentheses right here. So I've got 4p equaling negative 12. So therefore, if I divide by 4 here, p is going to equal negative 3. And that tells me that it opens down. So now, knowing that vertex is going to be a maximum because we're going to open down here, I'm going to just draw that nice, easy parabola that opens down. Alright, axis of symmetry time. X equals h. And h again and ours was negative 2. So I go over to negative 2, and I know right here that right down the center of it, which is at negative 2, I got my axis of symmetry. Okay, and then finally, or not second to last here, my focal point. Alright, h, what was h in our problem? Negative 2, comma k, k was 4, plus p, which was negative 3. That gives us a focal point of negative 2 and 1. So if I graph from the origin, negative 2, 1, I'm going to wind up with my focal point right here. And again, I'm on the inside of that parabola, so I know I did it right. And it's on the axis of symmetry. Alright, so last but not least, my directrix. Okay, so I got y equals k, and k was 4, minus p, so minus a negative 3, so that actually winds up being 4 plus 3. So you got y equals 7. So 1, 2, 3, 4, 5, 6, 7. And we have our directrix here on the outside. And we know we did this correctly. Now, one little cheat that we can look at, okay, is that if we graph this correct, the absolute value of our p-value is the same distance from the vertex to the directrix as the vertex to the focus. So if I take the absolute value of negative 3, I get 3. So if I count from here, I get 1, 2, 3. There's my p-value. If I go from my focal point to my vertex, 1, 2, 3, another 3. Those will always be the same distance, and it'll always be the p-value. Alright? So those are up and down. So now let's take a look. When you turn over the worksheet I gave you, we're going to take a look at right and left parabolas. Now, notice the difference here. The difference for this now is that y is first. So as you can see, it's y minus k squared equals 4px minus h. Now, X will always go with H. Y will always go with K. So if I'm still finding my vertex, HK, now I look over here. Now this is my H and this is my K. So my HK vertex here is going to be 5, 1. Alright, so if I go over here to 5, 1, 1, 2, 3, 4, 5, up 1, this is going to be my vertex. Now, because Y is first, this is going to open left or right. Now again, same thing we do here. We're going to take whatever's in front of the parentheses, 4P, and that's going to equal 16. Okay, so 4P equals 16. So therefore, P is 4. And since it's positive, we know it opens right. So I'm going to draw my parabola sideways now, opening right. So it looks like this. So now you can see, now our formulas are going to change a little bit. Our axis of symmetry is no longer a vertical line, it's a horizontal line. But I got Y equals K. And K in our problem was 1. So Y equals 1 gets us a dotted line going right through the center, and again that is my axis of symmetry. My focal point now changes a little bit too. Okay, so it's going to be H plus P comma K. So alright, H was 5 plus P 4 comma K 1. So this is going to be at 9, 1 for our focal point. So if I graph this, we got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 1 puts us here. And there's our focal point, again on the inside, no problem. Directrix, again, perpendicular. Now this is going to be a vertical instead of on a horizontal line because it's sideways. So I'm going to have X equals H, and again H was 5, minus P 4. So X equals 1 is our directrix. So that's a vertical line at X equals 1. So that's right here. And that is our directrix. And we label that DIR. Okay, so again, the picture looks the same. It's just rotated now to the right. Okay, so again, notice again, because it's right and left, the Y was first. On the up and down, the X's were first. So let's do the last one here. Okay, so here we go again. We got, excuse me, move that over there. We got Y plus 1 squared equals negative 4x plus 4 squared. So let's start again with the vertex. So again, looking at the formula, I know H goes with the X. So I'm going to have negative 4 because I got X plus 4 there. And then I'm going to have negative 1 because I got Y plus 1 there. So again, here's my H and here's my K. So I know that my vertex is at negative 4, negative 1. So I go 1, 2, 3, 4, and negative 1. And that is my vertex. Alright, which way are we opening? We're going to take 4P. Again, that's whatever's right here in front. I'm going to set it equal to negative 4. So 4P is equal to negative 4. Therefore, P is equal to negative 1. So that tells me a left. So when I go to draw it, I'm going to draw my parabola opening to the left. And again, we're not really concerned with how big or how wide or how skinny it's going to be. We just draw a nice easy parabola this way. Axis of symmetry, Y equals K, so Y equals negative 1. So again, negative 1 puts me right here through the center. And that's my axis of symmetry. Focal point, we're going to have H, and again H was negative 4, plus P, negative 1, comma K, negative 1. So negative 4 and negative 1, and we're going to have a negative 5, negative 1. So count from the origin, negative 5, negative 1. Puts us right here on the inside, so we know we did it right. And the directrix on the outside of x equals h, -4, minus p, -1. So that's -4 plus 1. So x equals -3. So vertical line here at -3. 1, 2, 3. We do that as a solid line. And we label that dir. Okay, so real quick again to test. P-value was 1, absolute value was 1. So again, I look from the vertex to the focal point, that's 1. And from the vertex to the directrix, distance of 1. So I know I graphed it right. So this should help you go through the worksheet. And make sure if you haven't already, subscribe to my channel. If you have to, make sure you go back and review and see how you're graphing up and down and left and right.